Hello everyone. In this video, we are going to discuss about finite and infinite sets along with the uniqueness theorem. But before knowing what a finite and infinite set is, let us understand what is an empty set. So let's define empty sets. So let me write here empty sets. Empty sets, as from the name it seems, these are the kind of sets which have zero elements. Sets having zero elements. These are the sets which have zero elements. I hope that it's clear. Now, this empty set is often denoted by this symbol. This symbol is known as phi. Now, pause the video and think for a while some examples of empty set. I hope that all of you have thought some examples of empty set. Now let me write. X there exists where x is smaller than 4.5 and greater than 4 and x belongs to I. I think that this is an empty set. What do you think? Isn't it an empty set? How could an integer exist between 4.5 and 4? There is no integer between 4.5 and 4. So in that case, this is an example of empty set. So we can represent this using this symbol, that is phi. Or simply we can write like this. This also represents a empty set, that is a set having zero elements. Now let's understand what is a finite set. Okay, but before going to that, let us understand that when we say how much number of elements a particular set has, so we can say that a set has n elements. We can say that a set has n elements. We can say a set has n elements when there exists a bijection between this set and the set n which is equal to 1, 2, 3. Basically, in simple words, we are trying to say that for every corresponding element in the set, there will be one natural number. So in that case, we would say that this particular set has n number of elements. I hope that it's clear till now. Now let's move to finite set. So what is a finite set? A set which is finite has n elements or is an empty set. Let me again repeat it and write it on the paper. A set which has n elements or has zero elements. It may have n elements, some natural number n, or it may also have zero elements. In that case, we say that this particular set is finite. Now pause the video and write some examples of finite set. I hope that all of you have written some examples of finite set. I think that I have taught you enough that I don't need you to tell some examples of finite set. Now let's move on to the definition of infinite set. So what is an infinite set? A set S which is not finite is an infinite set. Now what does this mean? This simply means that suppose there is a set S. There is no way that we can say that this particular set has n elements. Basically, there does not exist any bijection of that particular set S to this set. So in that case, if that set cannot be said to have some n number of elements or have zero element, then what it would have? It would have infinite number of elements. In that particular case, we call these kind of sets infinite sets. As I have written over here, is an infinite set. I hope that it's clear till now. Now we will move on to a theorem that is known as uniqueness theorem. Uniqueness theorem. So let's see what does the uniqueness theorem say. So let's write a heading over here. Uniqueness theorem. What does this uniqueness theorem say? So this uniqueness theorem says that if S is a finite set, suppose S is any set which is finite, then it will have number of elements n, and that n would be unique. So what does this uniqueness theorem say? That suppose S be a set, it will have n elements, and this n would be unique. Isn't it very understandable? And it comes out of our common knowledge that obviously if there is a set and it has finite number of elements, then definitely that n would be unique. Because suppose we have been given a finite set, if it has 10 elements, then it can't have any other number of elements than 10. It won't have 12, it won't have 15 elements, it will just have 10 elements. So any set which has n elements, that n must be unique, and this is what the uniqueness theorem says. Now there are some more theorems which we get from the understanding of uniqueness theorem, so let us understand them. So let's start. So the very first theorem that we go after understanding of the uniqueness theorem is that if A is a set with m elements, suppose A is a set with m elements, and B is a set with n elements, suppose there is another set B that has n elements. If A intersection B is phi, then A union B will have m plus n elements. We can prove it via theory as well as by using Venn diagram. I am going to prove this by using Venn diagram. So let's make a Venn diagram over here. Suppose this is a universal set. In simple terms, you can understand set which has all the elements that we are taking into consideration and some more elements than it. Now let this be set A. Now we will draw set B like this. Why like this, and why not making it intersect with A? Because here we have been given that the intersection of set A and B yields a phi, that is a empty set. So A and B have no intersection between them. Now A has m element and B has n element. So the number of elements in A union B would be m plus n. I hope that it's clear till now. Now suppose that we have one more theorem. Let's write that over here. Suppose there is a set A which has m elements, and we have set C which is a subset of A, and both of them, A and C, has one element in common. A union C has one element in common. The number of elements that is common in A and C is 1. So if you are asked that what would be the number of elements that A subtract C or A out of C will have, so A minus C or A component C will have m minus 1 elements. I hope that it's very simple to understand why this is happening. We have also done it in the earlier videos in which we understood complement of a set. I hope that it's clear till now. Now let's move to the next theorem and the last theorem that we are going to deal in this particular section. Suppose if C is an infinite set, and B is a finite set. Suppose there is a set C which is infinite, and suppose there is a set B which is finite. Now in this case, C component B would be a infinite set. This would be a infinite set, and it's very understandable. in this while taking complement, what do we do? If you don't remember, or if you have not seen that particular video, let me make you understand what do we do while taking component. Is that we subtract the common elements in these two sets with C. So suppose there are all elements of B are common with C, then also if we subtract those elements from C, then also we will have infinite number of elements. So in this case, I hope that you understand why C complement B is an infinite set. This was it for today. In next lecture, we will understand about countable sets, uncountable sets, and similar things. We are going quite in depth in real analysis, and you can write the kind of doubts that you are having. I will try my best to clear all of them, and I will be quite happy to help you out. Again, in the last video I had given you some problems. I hope that all of you have solved them. Those problems were quite easy, and those problems would have helped you quite a lot in understanding mathematical induction, and ultimately they would help you in solving some more proofs in the coming section of real analysis. I hope that all the things that I told you in this video is clear to you. Thank you very much for watching the video.